everyone, welcome back to Let's Unbound. Yes, we are solving Fermat contest past paper, that is 2025 paper. And yes, we are in part 3 of the series, and this is the final part. And here is where we will have more complicated questions. And yes, I'm going to show you how to solve this and what are the concepts so that we can start applying this, and also make sure you're noting down these concepts or the strategies that might help you in your Fermat journey, right? So let's get started. 21, which is part 3, first question. The area of a right angled triangle is 54 centimeters squared. The side length of the triangle are A centimeter, B centimeter, and C centimeter, where A, B, C are positive integers, with A less than B less than C, so C being the highest, right? And what is the value of C? So first, it's a right triangle, and that is C is the hypotenuse because C is the greatest, right? It's right angle here. I'm just placing A and B, any one of the legs you can name it. And what would be the area? Half AB will be the area, and that is equal to 54, right? So now, what is AB, right? So AB would be 108, right? So it's a right triangle. What else I can do? AB is 108, means many combinations possible, but they are integers. A, B, C, all are integers. So it should be a Pythagorean triplet, right? So let's find it. A, like 108, you can like break them into factors, 108. But when you square and add it, you should get another square, right? So 1 square and 108 square, it's 109, which is not possible. So 2 and 54, it's quite not possible because 54 square ends with 6, 2 square, like it's 4, right? It's not. Then 3, is it possible? Yes, 3 3s are 9. And reminder 1, 36. So 36 square plus 3 square, is that possible? We have to check, right? So 6 square is 36, 3 square is 9, 15. It ends with 5 means it should be the base also should end with 5. So it's not a perfect square. Next, 4. Is it possible with 4? Yeah. So 4 2s are 8, 7. 4 and 27. 27 square and 4 square, that might not give a C square. So 5 is not possible. 6, I think, yes, it's possible. 1 times 6, 8. And then 8 is possible. Yes, 8. 1 times 8 is 8. Reminder 2, oh, 8 is not possible. 9, yes, possible. 9 is possible. 12 times 9. Maybe this 3 times 3, the main Pythagorean triplet, we can connect it, right? 3 times 3 is 9, 4 times 3 is 12, then 5 times 3 is 15, right? So you just add 9 square plus 12 square, which is 81 plus 144, which is equal to 225, and yes, it's 15 square. So this is the only combination possible. So A is 9, B is 12, and C is going to be 15. Because A less than, B less than C, like smaller to bigger, we should order. So what is the value of C is the question? It's 15, right? And hence the answer is 50. Okay, 15 centimeters not needed because they are just asking value of C, not the length, right? Next question. The triple integers satisfies the following system. The integers are x, y, z, and 3 equations given. 3 unknowns, 3 equations. If p is equal to the product of x, y, z, what is the integer formed by the rightmost 2 digits? Okay, how to approach these kind of problems? First, you start with 2 power x, 2 power y. This and this, I will just eliminate as much as possible and make a single variable equation. So 1 and 2, they have 2 power x, 2 power x common. So I'm going to subtract 1 from 2. So what happened? 2 power x plus 2 power y plus 3 power z equal 6633. Then minus 2 power x minus 2 power y minus 3 power z minus 1 equal minus 2259. Okay, so this is my strategy. So finding one at a time. So this will get cancelled. 3 power z minus 3 power z minus 1 equal to, when you subtract this, you will get 4, 3, 7, 4. Okay. and try to simplify this. You can take a 3 common out. You will get 3 power z common out. You will get 1 here. 3 power z is out means 3 power minus 1 equal to 4 3s are 4. Okay, let's continue. So 3 power z, 1 minus 3 power minus 1 means 1 by 3 equal to 4 3s are 4. So 3 power z into, when you simplify this, it's 2 by 3 equal 4374. And this you can combine. This 3 power z divided by 3 will become 3 power z minus 1 equal to 4374 by 2. 3 power z minus 1 is when you divide like simple division, which is 2187. Okay, so to find z, I should do what power, like 3 power what is 2187. So 3 power z minus 1, you can try 3 power maybe after till 5 you might do, right? So 3 power 6, 3 power 7 will be exactly 2187. So that's it. And z minus 1 is 7 means z is 8. Finally, we got 8. We should find xy and then product them. So how to find x now, right? So take anyone, like I'm going to take this equation. Here, if you use, you will have like 2 power x plus 2 power y and 3 power z. Do you have that? Okay, 3 power z means 3 power, or you can use this also because we already have 3 power z minus 1, right? So why should I do 3 power 8 and waste time? Okay, so let's save time here. Actually, it's got it. It's 2187. Okay, so I'm going to take this equation, right? So what I'm going to do is 2 power x plus 2 power y equal double 259. This one is double 259. And what happened to the 3 power z minus 1? It comes to the other side as minus. I know the value of 3 power minus 1, which is 2187. Right? So 2 power x plus 2 power y, when you solve, it would be just 9 minus 7 is 2, 15 minus 8 is 7. So 72. Okay, I'm going to do it in next page. So we got this 2 power x plus 2 power y equals 72. So 72 should be written as sum of two things. Which of the two things should be power of 2? Like 2 power cube is 8. Again, 2 power cube if I use, no, 2 power 4 is 16, but it will not add up. Okay, let me try different. 2 cube with maybe 2 power, no, 6, 8, 2 power 6 is 64. 64 plus 8 will give me 72. So this makes sense. So 2 power x plus 2 power y is 72 means 2 power 3 plus 2 power 6 equals 72. Okay, here the order doesn't matter. So x is 3, y is 6. We already find z is 8. Now multiply all this. 3 times 6 times 8. 24 times 6. I'm just multiplying this and with 6. 6 4 is 24. 2. 6 2 is 144. And the question is, they are asking about the last two digits of this product. So which is 44. Right? So what is the answer? The answer is 44. Right? So that's simple it is. Right. So we are into next problem, question number 23. When two ants work together, they can build an anthill in 24 minutes. When the bigger ant works alone, an anthill can be built in 14 minutes, less than when the smaller ant works alone. So how many minutes does it take the smaller ant to build an anthill when working alone? Okay, so actually this kind of problem, like time work, so we should always start with the rate. Rate means in the one work can be done, like the work can be done in 24 minutes, mean in 1 minute how much time, how much work will be done, right? The unit rate should be done first. So that is how you should start these kind of problems. So first, bigger ant and smaller ant is there. Bigger ant worked like the work efficiency is not directly given. It's compared with smaller ants. So smaller ants work rate is, the complete work will be done in, it's not given. So yes, if it can do it in S minutes, then part of the work will be 1 by S. Okay. In 1 minute, it can do 1 by S of an hour. So if you can do a work in 5 minutes, or if you can do a work in 1 hour, in 1 minute, how much work you can do? Like that, if that asks, it's 1 by 60. Okay. So that is how it should be 1 by S. And then bigger ants work done. I mean, bigger ants work rate is, it's compared with smaller ant. If the smaller ant can do it in 30 minutes, it will do 14 minutes less than it. So work rate also will be S minus 40, right? This is important. Then together they can do. So when both are joined together, so of course the work will be speed up. So small ant plus big ant, if they do, work rate would be 1 by S plus 1 by S minus 40. That's simple. Okay. And they can do it in 24 minutes. So the unit rate, like they are asking about time, we are converting into work rate 1 by 24. Right. That's it. We can start solving for S because we should find how many minutes does the smaller ant take. So you cross multiply this S minus 14 plus S divided by S into S minus 14 equal 1 over 24. Right. So we will get 2S minus 14 divided by S into S minus 14 equal 1 by 24, and you can cross multiply. Okay. So 24 into 2, 48S. 24 and 14 if you multiply, 336. Then this side it's S into S minus 14. So 48S minus 336 equal S square minus 14. It's going to be, so convert into quadratic, X square minus 48S. Okay. Minus 48S and then minus 14S minus this, we are shifting these here, plus 336 equals 0. Now S square minus 62S plus 336. Okay. Now you can just solve for F. So 336, let me divide by 3, and it's 11 times 2 times. Now 2 table, 5 times, 6 times. So 56 and 6 combination I can try. 56, 6 add up to 62. For sure, they are from prime factorization of 336. Product, sure it should be 336. So yeah, so S is going to be, when you multiply them, it's minus, oh sorry, when you multiply them, it's 336. So both should be minus. And when you convert to S, it will be S is equal to 56 and 6. But what matters here? According to the problem, if small ant takes 6 minutes, big ant will do it less than 14 minutes. For big ant, it's 6 minus 14 minus 8, which is not possible in time. So 6 is impossible. 56 is possible. Small ant take 56, bigger ant will take 56 plus, minus 14. It's going to be 42 minutes, right? This way we can do, and 56. Actually, they're asking for only small ants. Uh, answer. So answer is going to be 56 minutes. Okay, we'll just write the numbers, right? So that's simple this problem is, and we are moving into next part. Suppose that f of x is x power 4 px cubed qx squared plus rx plus s for some real numbers. In addition, f of 1 is 59, f of 2 is 118, f of 3 is 177. If t is f of 9 plus f of minus 5, what is the sum of the digits of the integer equal to t? Okay, so actually when we see the question, what we will think is we will just try to plug in and make equations, find q or s. No, not that way. When you carefully observe something here, you can see that there is f of 1, you see, it's 59. F of 2 is 2 times of 59, which is 118. F of 3 can be written as 3 times of 177. Right. So if you have this, then you can write f of x minus that whatever constant is multiplying, 59x, right? We'll have the factors, like we'll have zeros at x is equal to, what are the constants, like 1, 2, 3, 1, 2, and 3. Okay, so this is a rule, and so we are going to apply this. F of x is equal to if this f of x minus 59 has a 0, so let me write. Then how will you write a polynomial? X minus 1, x minus 2, x minus 3, and one more. Because it's fourth degree polynomial, one more number we don't know, x minus p. So we want f of x, right? Because I want f of 9 minus 5. So x minus 1, x minus 2, x minus 3, x minus p plus 59x. This way, because it's quite simple and it's not much variables here, right? So now you just do what is, okay, we are going to use this and I will just plug in 9 and minus 5. I will simplify this. Okay, let's see. So f of x is this, x minus 1, x minus 2, x minus 3, x minus p plus 59x. Let's do the next part. F of 9 plus f of minus 5, right? So let's do, if you plug in 9, 9 minus 1 is 8, 9 minus 2 is 7, 9 minus 3 is 6, 9 minus p, and 59 into 9. Then, if you plug in minus 5 and minus 1 is minus 6, right? Minus 5 and minus 2 is minus 7. Minus 5 minus 3 is minus 8, right? Then minus 5 minus p, then 59 into minus 5. Okay, we are not going to multiply because most of them seem similar. So let's do something here. So 876 can be taken common. Here also you can see 876 in product. So take it outside. 876 and you got 9 minus b here. What about here? This minus minus will become plus. This minus minus, because if you take minus out, if it's 5 plus b. So 876 and all minus become plus. And what else remaining? 5 plus b. And here 59, you can take common from these two. And you will have 9 minus 5 left. So minus p plus p will get cancelled. 7 8s are 56. 6 into 9 and 14 is 9 and 5 is 14. Plus 59 into 9 minus 5 is 4. Right? And then you can simplify this. So it's a normal multiplication. You can multiply and add to get the number. Right? So this is the process we should do, and you will get 4940. This would be 56 into 84, and this would be 236. Eventually, you will get 4940. But they are asking, this is your t. That's okay. Your t is 4940. The sum of the digits of t is what they are asking. Right? So 4 plus 9 plus 4 plus 0, which is equal to 17. So the answer is 17, a prime. Right? That's simple. I hope you learned one technique about polynomials today. Right? Yes, so we are into the last problem, which is question number 25. Let's see. A sequence A1, A2 has A1 is 1, A2 is 3, and AN is given. They have given a recursive formula, right? For each integer, n is equal to 3. N is actually greater than or equal to 3. Okay. For example, they have just worked out how many of the 2025 integers, A1 square, A2. So A1, A2, A3, they give you this. And another sequence is squaring those is given. So in that squared sequence, how many of the integers will be divisible by 2025? Okay, so here we will apply modulo arithmetic, right? Because it's huge set of numbers, right? So first you can just observe what the sequence tells us, right? So A1 is 1, A2 is 3, then negative 3 plus 1, which is negative 2, the negative of negative 2, like the previous number, you should change the sign and add with the previous number. So positive 2 plus 3, 5, right? And then just continue and negative 5, negative 2, negative 7. Like that, you have to continue that and be careful. If you do a little error, it will affect your answer and you might stuck for a long time. Okay, so I'm just filling this as I have already did this. Right, 81, 131. Let's see if we got any pattern here. 2 1 2. I think most of them are palindromic. triple five eight nine eight. I mean negative 898. Like it's going on and on. So right. Um. Okay. So now, divisible by 2025. The squared number should be divisible by 2025. So 2025 means what's 45 square, right? So I'm just gonna check which is divisible by 40. Anyways, I'm gonna square it, right? So let me find A congruent B mod 5, like 0 mod 5, because it's divisible by 5. So which this is divisible by 5, this is divisible by 5, this is divisible by 5. So which terms are divisible? Fourth term, 4, 5, 6, 7, 8, ninth term, 10, 11, 12, 13, 14th term. And you can see 4 plus 5 is 9, 9 plus 5 is 14. If you follow this, for sure, 14 plus 5 is 19th term will be divisible. So we got one thing. Next is 9 times 5 is 45, right? Because we are looking for 45 first and not just to 2025, okay? So A congruent 0 mod 9, like divisible by 9, I'm going to check. So first divisible by 9 is 81, right? Which is ninth term, which is 10th term. Then if it's not there, just do it because we should know what after how many terms it's going to be divisible by 9. So first term is 10th term is divisible by 9. So we should find it. So proceed this. And if you go on and on like this, 26073 will be an element, which is 22nd element. I mean the term. So 22. It's adding 12. So next to 34. Right. So, but you want the first common. We are just looking for the least. So after 14, if you add 5, 19, 19 with 5, it's 24, then 29, then 34, then 39, like that. So here, 34 and 12 is 46, 46 and 12 is 68, 58, like that. But common first is, this is divisible by 5, and 34th term is also divisible by 9, so it's divisible by 45, and we are just looking the square of it, okay? So yeah, it's 34th term, and 34th term is the first term which is divisible by 5 and 12. What is the next term? Is it only one term? No. In this 2025 terms, I mean 2025 terms, the first term which is divisible by 45 is 34. What is the second term? Just the LCM of like this 12 and 5 is just 60. So after every time, after the LCM value, it will occur together, right? So 60, if you add 94, and again 154 and 60, 214, like that, it go on and on, right? So yeah. So what should I do with this? 34th term, 94th term, but I should find how many of these are actually divisible by 2025, right? So you can't continue a sequence till 2025, but let's see. They are integers, right? So it starts with 34, and the general term of the sequence is 34 plus 60k. It should be less than or equal to 2025. And I should find for what is k. Okay, this is your sequence actually. 34, 94, 154. So subtract 34 on both sides. 60k. This is simple solving you can do. And you will get 1991 divided by 60 on both sides, which is k is less than or equal to 33.18. So k is 33. But it's not 33 integers. It's not in the list, it's 33. It starts from 0. If you give 0 for it, it's 1. So 0 to 33, how many integers, like how many things will be there? 34. So there are 34 numbers which are divisible by 2025. Okay, it's 34, right? And yes, the answer here is exact answer. It should be 34, no other answer possible here. So that's it. We complete all the 5 questions. I hope the strategies and the way we explained here for you today is helpful to you. If yes, you can drop a like and so you can subscribe to us So do watch the other videos also, which is related to format, which is available. And yeah, practice more and stay curious. I will be meeting you maybe with another paper walkthrough. Until then, keep learning and keep practicing. Stay curious.